vamos a hacerlo con esto. Bueno, para los que no me conozcáis, bueno, esto es hace 10 años, cuando estaba más delgado. Esta es más realista. Bueno, Enterprise Dev, llevo de 8 a 10 años, creo, programando, sobre todo con Java, desarrollo web, bueno, todo así y tal. Esto es lo que he puesto en el LinkedIn hace poco, con la esperanza de que me contraten o me paguen más. Bueno, no es que esté mal aquí. Y esto es lo menos triste que puede encontrar de mí. Aquí tenéis la foto para ilustrar. Ok, esta charla. ¿Cómo programar en Perl como si fuera NodeJS? ¿Quién de aquí no habéis hecho alguno de los dos idiomas?
Que no hemos hecho.
Exacto. Bueno, es una pregunta un poco retorcida. ¿Quién no ha hecho NodeJS?
Bueno, yo puedo decir que he hecho NodeJS, pero casi te diría que no.
Pero como
Vale. Okay, and I guess everyone here has done Perl at least once. Okay. Hola. ¿Estáis para echarlo o para que es buena? Lo siento por vosotros.
Ponerosla aquí.
So, as I've said, I've been working 9 years as a web developer, and only 3 months in Perl. One of the things I missed the most when I did the change was asynchronous programming. This is what I was used to with NodeJS. And the first thing I thought was, how the hell do I do that in Perl? This is what we're going to see in this talk. But first, we must define what is async programming, what are Node.js developers, and all the things we're going to use. So, without further ado, let's see what the Node.js devs. Those guys. So, as they say in my social club, you know them by their words. First one is async. Async is a way of living. You just do async, or you do not. But in fact, no one really knows what is async. Especially if you are a Node.js dev, you don't really know what it is. But you tell about it. Mongo is a synonym for database, standard database. It's what you use when you program in Node.js. You use Mongo as a database. This means that inherently, when you program with Node.js, Mongo, and async, everything is web scale. It's a property of programming with Node.js. You don't really program with Node.js, you do it with JavaScript, but nowadays, no one calls JavaScript JavaScript. Just, that's a very old name to it. You call it ECMAScript. You add the version number you want. You call it Node.js, although it's false, not Node.js. But well, that's it. Threadless. Node.js is an execution engine and an environment. One of the reasons it's very fast and web scale is because it doesn't use threads. Or at least that's what they say. And finally, this is more a legacy from the past, from the Ruby hipsters. But I can say from experience that I do that. I go to Starbucks with my Mac. And so, in short, these are the Node.js developers. I'm sure you have done some programming before with Node.js. You will feel identified with this. And let's talk about the Perl developers. In fact, that's my development environment. I have been somewhere, and once you have been, you don't need anything else. So one of the great things about Perl is that since it's so bare bones, out of the box it doesn't come with so much functionality. Things like asynchronous programming, you have to work for it. You have to learn how it works. Because in NodeJS, it comes out of the box. The thing is, in fact, it is hidden. The NodeJS developer doesn't know he's doing async programming, usually. Because behind the scenes, NodeJS is running something that allows to perform asynchronous programming. But Perl is not like that. So that was my case. I was used to NodeJS and synchronous programming. I knew how it worked. But when I tried it in Perl, it didn't work. And what I liked about that is that I had to learn how it worked. And this is what we're going to see. So, the most important thing, at least for this talk, is when you program with NodeJS, we're doing asynchronous stuff. And what is asynchronous stuff? The thing is, it's a paradigm of programming. It means the main idea behind asynchronous programming is that your code is not the bottleneck of the application. It's your interactions with external systems, like fetching the content of a file, or retrieving the contents of a website somewhere, or accessing a database. Those things takes a lot of processor cycles that are wasted usually because you're waiting for them to return. So if your application is spending most of its time accessing external systems, you should be able to use those wasted cycles. And synchronous programming is trying to do exactly that. Instead of waiting for a result, do more work while it fetches those results from external systems. It's not for all applications. It's basically applications that are really event-driven, like our browser, for example. It's a perfect example of an asynchronous environment. Also, a server, a web server, for example, on a REST API. They're usually waiting for requests or events to execute code. So I'm going to show a little example because code speaks louder than words. Oh, okay. When you do async programming, it has a function that does something that will fetch an external system, and when it returns from the external system, it will call your code to execute. So for example, this function receives a parent and receives a function, a callback function. It will do its work and return before, before doing the work. Because the thing is that you don't want to wait. You don't want to wait for this thing to finish before continuing to do your things. So for example, this code, it will do something. I'm invoking it here. I'm saying, okay, once you've finished, you execute this thing. And after declaring, I want to do this, and that I will handle it with this function, anonymous function, I do some other work. In this case, it's just a print, but it could be something else. This is still synchronous, but we'll see how we do this. Okay, title is more important than the code. I don't see the scroll thing. Ah, because there isn't. in the previous example, there was no benefit whatsoever to using asynchronous programming because it was a very simple script that just executed linearly what it had to do. So in fact, you could do the same thing synchronously, and it would be exactly the same thing. I'm doing this, and when I'm finished, I write this. But even for simple scripts, we can benefit from using asynchronous programming when we're doing operations that take some time, many operations that take some time, and we do not want them to be serialized, one after the other. For example, we have this function that fetches the content of a website somewhere, and I have many websites I want to fetch. This is synchronous. It has no synchrony whatsoever. So in this code, it just iterates, fetching each content, and it prints it. The execution time of this is the execution time of each of the fetching, one after the other. We can do better than this. With asynchronous programming, let's say I just want to print what I receive. I define a function, a handler. Here, it will print whatever it receives. I have my fetch function, which will retrieve the content on another thread, and will call the content handler callback when it is finished. And when when I call this code, for each of the URLs, it will fetch here, but it will return immediately. It will not wait to fetch the content which is in another thread, but it will know how to handle that content, because I have defined here callback, the print function, I'm referencing it, and it will do its work. So the idea here is I'm fetching all these URLs, and when I'm receiving them, I'm just printing them. So the execution time of this is the slowest fetch of all the URLs. So for a script, this is one of the ways to benefit from asynchronous programming, by doing parallel work and fetching, reacting asynchronously to that work. Scripts are not the most important things about asynchronous. Usually want applications like servers to do this, but you can still benefit from it. The thing is, the code I've been showing does not work. Lying. If it had been written in JavaScript, it would have worked. Not because JavaScript is better, but because NodeJS, as an execution engine, initializes what it needs to make that work. In fact, if we go to the code, what will happen is I have my function here defined, and I have my loop. It returns as soon as it declares the thread with the work it has to do, it returns. So what it will do is iterate over the callings, and then it will end. The script will end. Everything will end before even the first fetching has been performed. And when it has returned, like if it returned from that before being closed, well, there's nothing here to attend that that handling. So as it is in Perl, this code will not work. And for this, sorry, that's because NodeJS uses an event loop. An event loop is the mechanism that allows to perform asynchronous work and wait for it. Oh. Okay, we have our event loop. This is our code. It will perform requests that access external systems, and the event loop will put that request, which can be any kind of external system. It will put this code, this external code. It will put it in an event queue, and it will continue to run the other code. So your code runs, and then somewhere it stops and waits for new events to happen. When a new event happens, it will take it, it will process the handler that you defined for this code, as we did for our code before. We always said perform this operation and then call this function to handle the result. So it's exactly the same thing. The event loop will always look for new events and execute its handlers as they're happening. What it does is basically for each external code, it will create a thread to execute that external code. It will execute a new thread and return with the results in a single thread. I put the word before threadless. It's completely false, but the main event loop runs on a single thread. And the single thread keeps running forever until you tell it to exit this loop. There's not really much more to this. It's a bit complicated when you see it first, so if you have any doubts, I can answer that before continuing.
Two things. The first one, if you set an infinite amount of callbacks, it breaks the system, or there's a limit?
There is not really a limit. When you say infinite,
I mean, instead of 5 sites, you like 1,000 sites.
There's no problem with that. The loop continues generally until it exits, and there's no limit to that.
And here's that, like a scheduler to should only do some things at a time, or they do everything in parallel.
At least in Node.js, there is no scheduler that arranges each event as the first it puts, and it's the first that it executes. And in fact, the main blocking thing is your code. If your code takes too much time, then the rest of the code won't execute. Since the event loop is a single thread, the rest of the code won't execute. So when you program asynchronously with an event loop which is single thread, you have to take care that your code does not take too much time to execute, to allow the rest of the code to execute.
And so here registers all the callbacks, and then when the last one is finishes, ends the code.
Yes.
And event loops tells the main program that I complete all your 2 calls and you can end now.
Yes, we're going to see that with Perl. Node.js, I guess it just looks if there isn't any event left. In Perl, you explicitly, at least with any event, you explicitly tell him, okay, I'm finished, and you can exit. That's event loops. In general, that's the Node.js event loop. Behind the scene, they use a library, C library, which is libuv. It's the event loop that it uses. In Perl, you can use this too. That's a library that interfaces with this C library, but it's not the only one. As always in Perl, we have a lot of choice about what we want to use. The amusing thing is that they are incompatible between them. So if you use one, you cannot use the other, except if you use any event, which is the one we're going to use.
just to make a distinction there, the difference is the syntax versus the loop itself. And PO is not on the list here, but PO, for example, supports a syntax PO and underneath any one of like, I don't know, 7 different event loops underneath. So you could write PO with EV underneath or UV underneath. You can
Okay,
write
I guess it acts like an event in that sense?
yes, it came before an event. IO
okay.
async, which is also not on the list. I guess the O there is like IO async.
Yes, it's iOS.
Right,
Yes.
right. So IO
I
async
call it
does
that.
no, that's fine. I have way more typos. But the IO async does allow that too. So they separate the syntax.
In fact, this list is the compatibility list with any event. I took it from the documentation.
Yeah,
And there are
EV is
more
a
now.
loop, event is a loop, glib is a loop, TK is a loop, UV is a loop, event lib is the lib event loop. Any event IO async and PO are syntaxes that have their own implementation of a loop, but they could use the other loops as well. I think
That's
just
true.
to clarify that part.
That's true. In fact, when I'm going to talk about any event, it's just that. It's a wrapper that uses other event loops if there are, or if there aren't, it uses its own. In case of any event, it uses pure Perl implementation of an event loop. Okay, so how do you use an event loop in with any event? The idea is you have a condition variable which serves as the blocker, the thing that will wait for events to happen. So you have your condition variable here. You declare it with an event convar, which is a constructor, and the loop starts here in this function. The condition var receive. When this line is executed, it will start the loop and wait for events to happen. Whatever happens here, it's still not inside the loop. It's here. This function will wait, will block the code until it has received another function which is called send, which we can see here with this example. I guess another 20 minutes. Okay. This one function is from before when we were fetching URLs. I have my exit condition bar here, which is when the program will end. And I have my URL, my fetch URL call with my handler. The handler does whatever it has to do with the content it receives, but it also says, when I'm done, when I have received asynchronously what I intended to fetch, I'm going to end the event loop by using send. It's not very intuitive, receive and send as starter and enders of loops, but it's how it's used. So
I believe Javi's having a great time right now.
Oh yeah, I'm enjoying.
He's enjoying.
why are they called like this? It's not random. In receive, I'm going to receive whatever I send here as a parameter. In this case, I'm not sending really any info, extra info. I'm just wanting to end the loop. But I could send the content of the URL that was fetched, or whatever other value I want, and it will be resolved with a variable that have my content, for example. I could receive that. So with any event, it's the event loop that allows us that with the code that I showed before. That's some inspiration. That's a blessed Larry Wall clock. Blessed by Larry Wall himself. Okay. We have the same thing as before. The function with the handler, and this all works now because there's a condition variable, there's a event loop handler that runs and executes this code. That's the basic use. Let's imagine we want to retrieve many thing is my handler, if I'm going to retrieve many URLs, my handler cannot anymore just say, okay, I have received the content, I can now exit. Because I still have 3 more URLs to fetch. In this case, I'm just using a fetch count. When there are 4 fetches, then I can exit. This gets quickly very complicated and convoluted to handle when you have a lot of things to retrieve asynchronously. So, to handle this complexity, we have this. Promises. Promises are a way to handle the callbacks. An elegant way to handle callbacks and general asynchronous operations when things get a little bit more complex. So since it will get a little bit complicated, I'm just showing you some code with this. Promises is, the concept is, a promise is a work that will be done. And you receive an object to which you can react and say, okay, when the work that this object will do is finished, I want this to execute. The syntax, you're seeing all well behind? Mm-hmm. Okay, the syntax is the important thing. This is my function. My function, I'm going to look it later, returns a promise. And I can chain what I want to happen on different conditions. If it all executes well, then I want to execute this code. If there was an error while executing this, I want to catch it. Okay, I'm trying to be super fast now. Okay, it's a lot like a Java try-catch thing. You have the then, the catch, you have finally. In this case, I want to retrieve many URLs, and I do my thing. If there are any errors, I show. And finally, the last thing I want to do, independently if it has gone well, bad, it's this. I want to exit my vendor. This is the case for just one fetching. I'm going to look the case for many ones. We had a problem before with retrieving many URLs. I had to build a fetch counter, which is very ugly. Promises can be chained. And this means I can call many promises. My function returns a promise. I'm going to look after that how it is done, but my function returns a promise. So I can chain many of them with this function, correct? And when all of them are done, I have my then here, and it executes whatever it has to execute. Okay, as for the promises themselves, there's really not much complication. A promise, you initialize it with the deferred keyword. You have a variable. And on the function, you can either resolve the promise or reject it. So in this case, I'm going to a different thread to perform my work, and when it returns, and it has returned well because it has no errors, I say, okay, resolve the promise with this result. And on my function that I have created the promise, I'm just returning the promise itself so that it can be used directly with the then, catch, and final keywords. If there had been an error, I would write the reject and whatever reason I want. Since we're running out of time, I cannot really show you much more. So, just so promises are not the only way to handle callbacks. We also have futures. futures get much more complicated than promises, but they offer a lot more too. The thing is, there is not inherently a better option than the other. It's just for your need, you use one or the other. And that's all.